Hey everybody, welcome to more math help. Today we're going to be doing a review assignment on graphing and writing exponential functions. These are from these lessons from our book. I guess that doesn't really matter that much or whatever. This is in preparation for a test that's happening at the time of this filming tomorrow. 16 questions on the review, 16 questions on the test. So closely following each type of question on the review will help the test be better because you will, like, question 1 is just like question 1 on the test, and question 4 is like question 4 on the test, and so on and so forth. So if there's a particular problem you're struggling with, please keep that in mind. Like maybe like 16 is not your thing, you know what I mean? Like problem 16. Maybe take after this review, practice yours or whatever. When you're done, I would recommend tomorrow when you come take the test, go to the problem that gave you the most trouble first, and then do it. That way, it's out of the way. And if you struggle with it, I mean, it's no big deal. Do what you can. 16 questions sounds like a lot, but in reality, it's a benefit to have more questions. I'm trying to fit as many questions as I can that I think people can typically finish within one class session. Because if I made it an 8-question test and you missed one, you lost over a letter grade here. But with 16, you're still doing okay even if you miss one or two. All right, that being said, let's get this thing going. Graphing and writing exponential functions. Here we go. All right, so the first question, and there's not going to be a lot of similar question types here. Like compared to a homework, there's usually like 2 or 3 of the same thing. Here, there could be just one of a kind, by the way, so I think there's only one of these. I guess we'll find out as we go. I'm pretty sure. I did put some things that repeat, but this one I don't think so. All right, so to answer a question like this, it wants us to plug in 5 different numbers, -2, -1, 0, 1, and a 2 that's behind my head, and find out what the output is, like in this thing. That is a job, whoopsies, boop, for Alex? No, it's a job for Alex. Oh my god. I gotta get this right. Desmos. You keep naming one child the other thing. Okay, 1/9 to the x makes a little graph like that. Now you don't have to make a graph. You could sit here and like plug it in 1/9 to the -2 and 1/9 to the -1 and 1/9 to the 0. And if you want to plug them in like that, that's fine. I'm gonna use x and graph it. And here's why, because on this and on some future problems where I'm graphing, I'm going to want to turn this into a table by clicking the edit list and making a table out of it. Now you notice some of these are decimals. I'm telling you right now, for the 50th time, I had to tell a lot of people while I was reviewing this with students today, you cannot put these decimals. You cannot round these decimals. Do not put 0.1, do not 0.11, don't even do one of these. Some people I saw doing this where they were putting this. See how like it turns from fractionable to not fractionable? They go as far as they could and then do this and be like, okay, that's the fraction. No, I'm sorry. It's close to what that is, but it's not exactly the same, and that's what you need. You need exactly right answers. So let me go down my list here. I got 281, and this one is 9, and this one is 1, and this one is, now here's the deal. If it's like that, and this is why it's not a terrible idea to just go through and plug in the numbers. You have to literally plug in 1/9 to the 1, because that's how it got that number. See, it makes the same number. I hit the button, and it's 1/9. Duh, anything to 1 is itself, so I'm going to put 1/9 there. And then I'm going to do it to the 2, and it's already in fraction mode, so it tells me it's 1/81, but you can see it's the same as that. 1/81. You can't see the 1/81. I'm typing it behind my head, I promise. So that's it. You're just plugging in 5 different numbers and calling it a day. Now you're going to be doing a little bit more of this when it comes to graphing. So it's good practice to try it on a table first, just to make sure you can make the table. Like question 1 is, can you make a table? Question 2, graph this and graph it with these values, and then click on the graph icon there. Okay, so what I'm going to do is I'm going to come back over here and I'm going to type it in. Now you could type g of x like this, equals 4 to the x. If you just want to type 4 to the x only, that's not wrong. You can totally do that. It's fine. I'm going to hit the gear and turn it to a table. And what do you know? You get -2 to 2, which are the exact 5 points they want you to graph. Now here's the deal. On this problem, I got decimals. But these decimals are not repeating. Like, if it goes only out 4 digits or less, I would strongly recommend you just graph it as is. You can use decimals on Alex here, and the way you do it is click this little box and type them in manually. So -2, 0.0625, enter, -1, 0.25. Now the rest of them are all graphable without this little box thing, but I'm going to graph them because I'm already here. So 0, 1, 1, 4, 2, 16, boom. There's little dots on my graph here. Sorry, some are slightly above my head, a little hard to see, but they're there. Then I'm going to hit the thing here, make it a little line. Ta-da! Now here's the deal. If it wasn't so nice, like this is just an example. Hold on, let me hit check just to make sure we're right here. Okay, this is just an example. If this had been 7, see how some of these are bad decimals that are repeating or they go past 4 digits or anything like that? I wouldn't feel safe about trying to type that into Alex, because you shouldn't. But I would instead do what I was doing on that first problem and literally inputting 7 to the number. See how it makes the same thing, and then converting to a fraction. If you have to do a couple that are fractions, it's fine. Like, it's very likely to happen. I didn't get that on mine, but it's likely to happen. Here's one where it's likely to happen. Let me change my function up here. Uh-oh. All kinds of stuff going on here. Okay. Now you notice on mine I put g of x, though the problem says f of x. Not a big deal. Doesn't change anything. Still going to graph normally. And look at that. I got some decimals. I got a 1. And then I got some repeating looking decimals that are bad. So when it comes to the decimals at the top here, those are fine. 0.36. Although technically 0.36 is 36/100ths. And this one is 6/10ths. Totally use that. Okay, then we got 0, 1. That one's a free 0.2. Okay, now for these ones, I'm going to have to do what I said. I'm going to have to go and do 5/3 to the 1. See how it makes the same number? And not shockingly, something to the 1 is itself, so I'm going to put 5/3. I have to put 1 comma 5/3 because I plugged in 1, I got out 5/3. I plugged in 2, I get out 25/9. So that's what I'm doing here. I'm going through and I'm plugging in for some of them because some of them weren't nice. Okay, they're all plotted. Let me put this where you can see it. There's my points there. Okay, now I can't graph it. It asks for one more thing, and this is true of your number 3 as well. Draw the asymptote. The asymptote is the point in which the graph levels out and doesn't go any higher or lower. So I have to put a dotted line on the axis showing that that's where it goes. Now, people were asking today, is it always going to be on the axis like that? Yes. for this assignment, yes, technically. Okay. Is it always like that in reality? No, because check this out. If I put -2, you could see it levels out at -2 now. Or if I put -4, it levels out at 4. And things can get, differenter and differenter depending on like what stuff's going on here. But there you go. We're not seeing that on these problems. I'll tell you right now, what I put in there, they're not gonna be the kind of problems we're gonna see for now. Okay, 4 and 5 ask you to find the domain and range of the graph. So it's quite simple. Domain is always all real numbers because it's asking you how far left and right the graph goes. It's rising this way, but it is going left and it'll never stop going left. The graph's not suddenly going to stop going left, and it's curving down and going right, and it's never going to stop going right. So it's all real numbers. The range, on the other hand, refers to up and down. It does rise and it goes upwards forever, but it doesn't go down forever because it slopes and evens out right here, and it will never ever go below this dotted line. So the range represents like all the heights that are possible, and some heights are not possible because you will never see the line at a height that's lower than this line. So how do you write that? Y, the letter Y, because that's the letter denoting the range. And now you have two choices. It's either going to be less than or greater than. Those are the only things. Don't ever use these equals options. They're just there to trick you. Less than, greater than. Well, it all depends on how your graph is. Notice my line. It doesn't matter which way it's curving. What matters is that my solid line is above the asymptote, the dotted line. So I'm going to use greater than because my line is above that dotted line. And what is it greater than? -4. That's the place where the line's crossing, which means this. The height of my line is always above -4. Like, that, isn't that true? This is above -4. That's above -4. Even over here, it's getting close to -4, but it's always above. Okay, let's see another one of those. Hopefully this one's the other way around. Nope. Now this is curving upwards, but it's still above, so I can tell it's going to be... Here, let's just start with the range. Y is greater than, right, because it was above the line, -3. And again, the domain is all real numbers. Be careful. I don't know if you saw, but on mine they switched the order of the words. So make sure you're reading. Don't just assume domain is the first answer and range is the second answer, because that is how you can make a mistake. So read carefully, okay? I'm going to hit check on this. I hit try another. I really want to show you one that's upside down. Okay, so again, domain, all real numbers. Range is y. This one, y is less than. It's always below. In this case, -2. I'm getting a lot of negative numbers for the asymptote, but that's not always going to be the case, just so you guys know. There you go. I did one extra for you because I just wanted to show you what upside down looks like. So below is when the line is all below the dotted line. My first two were above. Okay, next. Graph this. Okay, we did some graphing earlier. Equals -2/5 2 to the x. Clear this other stuff out here. Okay, it says graph this, and it says use those points and draw the asymptote. We're familiar with this. This is what we saw a little bit ago, but a little bit ago it didn't have like an extra number multiplying out front. It's not really that different, honestly. You're still just using decimal stuff. That's funny. What are these weird results? Okay. Now notice these are not repeating decimals, so I am allowed to just type these all in right now without changing anything. -2. -0.1, -1, -0.2, sorry, I'm going to go fast-ish, 0, 0.4, 1, I guess go fast-ish, but don't go too fast-ish, 0.8, 2, 1.6, there you go. Don't forget to draw your asymptote, which is this dotted line, right? It's on the axis again. Notice it levels out right here. It doesn't go any further than that. And that looks accurate, so we're going to hit check. I really hope you have this process of using this table down here. And I really hope that I get to show you a problem where they don't always have, like, the nicest numbers. I think this one will probably be like that. Be super careful. I don't know why, but I saw people today missing this. Instead of putting 5x to the x, it's to the -x. So make sure if it's got a negative in that exponent, you don't forget it, because that will, if I forgot to put a negative here, the whole table gets reversed. See? Not negative, now it's negative. Not negative, now it's negative. So don't do it backwards on accident. All right, look at that. We got some decimals here. Now, this first one, I think, might be okay. I don't want to risk it, though, so I'm going to plug it in. -5/8 to that. Now, this is where you got to be super careful, and I'm so glad I got this one. Plugging in -2 gave me that outcome. So I'm going to raise it to the -2, like this. Sorry. The reason why I'm raising it to the -2 is because it has a negative, but I'm also plugging in -2, and you can confirm that it's right because it should match what's on the table. The table has the right numbers. So if you're trying to do your work and convert it to a fraction, make sure it looks like it matches the table. 25/64. Now you'll notice it didn't add any extra digits here, so I'm kind of under the impression that this is okay to put as a decimal, but I'm just going to put 25/64 because that is probably safer to do. It's not wrong. So I'm going to put -2, -25/64. And that's my first point. And then actually the rest of these look pretty clean decimals. I mean, clean enough. Not the best, but not the worst. They're not repeating, that's for sure. So I can go ahead and type this stuff. Okay. This one also wants the asymptote again, so dotted horizontal line. Again, flattening out at 0, as I said. They can be other places, but not on what we're doing. Okay. You know what's weird? I should really just switch the sides here. Check this out. Midway through the video, making it as pro play. I mean, why wouldn't we just do that from the beginning? I'm a genius. Or an idiot, one or the other. Actually, right here is funny because I don't need Desmos for this anyway. So it says graph 4 to the, here's 4 to the x. Graph 4 to the x plus 2 plus 1. Now, people, I realized that because it's a graph, it really makes you want to go to Desmos and type it in and see what it looks like. And I'm not saying you can't do that. So I'm going to show you how that looks. 4 to the x plus, hold on a second, plus 2. Notice I had to use a parenthesis there because it wouldn't. Looks like that. But how does that help you answer the question? It gives you a visual of what you might want to be looking for when it's finally done, but it's not helping you answer the question anyway. And even worse, I saw people doing this thing where they saw it crossing the axis right here and they were trying to put a point like that. That is not at all what you want to do. No, no, no. Here's what you're doing. You're taking this point 0, 1 and you're moving it such that it makes this graph, right? Now how you move it is according to what the equation says. So you'll notice this equation has plus 1 at the very end. That number at the end is an up and down movement. For example, if I were to erase this, see how it's like on the line? And I do this, it moves a little up. So what the plus 1 at the end of the problem does is it moves it up. So I'm going to move the whole thing up 1. There you go. That looks like the right height now. If it had been a negative, we would have moved it down. Now this plus 2 moves it 2 horizontally. This outside stuff moves it vertically. This moves it horizontally. But if I moved it 2 to the right, that doesn't look like the picture, right? So why not? Because the horizontal stuff, we discussed it in class a little bit, but the horizontal stuff is reversed. Plus 2 really means left 2. So literally, let me start that one over again. So starting from the starting point, the plus 1 at the end of the equation says it should go up 1, and the left 2 says it should go left 2. And that's not, it doesn't look exactly the same as that picture, but that's correct. It's the correct thing to do. Okay, there's going to be more of these, so let's keep them going. So on this next one, we got a plus 4 down here at the end. So that moves the whole thing up 4. And this minus 2 moves it right 2. I didn't even have to graph it to know what's going to happen. That's the goal. Like, can you graph it with like on this without even having to actually like use a graphing utility? Yeah, totally. Be careful though. See how this says plus 4, but my final height is at 5? Don't start in the center when you're counting. You're starting where the first point was which was at 1. That goes up to 5, because I've added 4, and then right to 2. Okay. I'll do less explanation even on this one. Negative 2, down 2, plus 1, left 1. That's how fast it should be. And I hope, please, gosh, I hope you get those right. Out of 16 questions, 3 is about, it's not quite, it's a little under 20% of your grade. So that was kind of the point of the chapter. Can you graph those things and can you see translations of the things? So that's why there's 3 of those on there, because I really want to make sure you can do it, okay? All right, now we're going to move into some calculatory stuff, maybe. I'm going to write this. I wrote this on the day I did the homework review of this. Don't mind me, just putting some formulas. Whoopsies to the NT. Okay, I'm putting 3 formulas here because there were 3 formulas on some 7.7 specifically lessons that had us dealing with exponential growth, decay, and compound interest. So the first half of this, by the way, was all graphing stuff. Like, can you fill out a table? Can you graph this? Can you graph that? Can you tell the domain and range of this? Can you graph these? Can you draw the graphs of these that have been shifted around? Oh my gosh, perfect. What a perfect test so far. The later half is, can you write these formulas? I mean, that's literally what the test is called, graphing and writing exponential functions, right? Like, that's why I called it that. Okay, so over here, you have to decide what's happening. At the beginning of a population study, a city had 220,000 people, and each year the population has grown 9.1%. Yeah, that's a massive growth rate. Let t be the number of years since the start of the study. So here's the deal. You have to decide what's going on. Is it growth? Is it decay? Is compound interest going on? It says the population has grown, so I hope that's a super solid indicator that you need to do a growth formula. So you fill it in. Y equals. Now you don't put any letters besides y and t because they only ask you to show the relationship between y and t. So the a and the r have to be numbers. And the a number is the starting amount, so 220,000 people. Please don't forget this. I saw people forgetting this. The inside of the parentheses must contain 1 to some degree, and then plus or minus. In this case, we're going to use plus because it's growth. If the population is growing, we do it. But we don't type 9.1. Do not put 1 plus 9.1. Ooh, that'd be so wrong. You have to convert 9.1 into a pure decimal number. And if you're having trouble with that, that means you divide it by 100 because percent means per each 100, which means divided by 100. So 0.091. Some people say the quick way is just move the decimal twice to the left, which is totally right. I'll raise that to the t because that's what the formula says. Now, it's traditional to combine this stuff in the parentheses together. I've come to find out that Alex does not care if you do that. It does, however, care for some silly reason that you put a comma in your 220,000, but I don't think it's ever going to mark anybody wrong for that, so feel free to do what I do on that one. All right, forest study says 1,500 kilometers. Since then, this area has decreased by 9.6% each year. So it's a decrease. So this is a decay problem. So y equals 1,500. 1 minus 9.6% is 0.096 to the t. And again, I could simplify the insides, but I'm not going to. Hooray. I don't know. This first problem was growth and this next problem was decay. I don't know if that's going to be like the order you're going to get. I think I put this to be growth or decay randomly. So you might get growth and decay. You might get decay and growth. You might get growth and growth. You might get decay and decay. I don't know what you're going to get. So don't assume anything, okay? Okay, this next one has given us a formula for a growth or decay problem. In this case, it's actually decay because decay is always if this is less than 1. And then ask you two questions. What's the initial value of a car model? And what's the value of the car after 13 years? So for the initial value, you don't have to look any further than the equation, 27,500. I'll put a comma just for you, Alex. And then 13 years, the value, okay? Do not put a comma in Desmos. So see if I put a comma over here and I start typing this thing in. Oh, geez. Why am I putting negative? There we go. This to the 13. It didn't give me an answer. Do you know why? Because it's mad that I put a comma because it says, hey, you're trying to make an ordered pair, right? No, I'm sorry, I'm not. So I'm just saying, I was just showing you don't put a comma in Desmos, but I guess if you want on Alex. All right, just make sure you fill it in right. 27,500.90, okay, to the 13. Please read this, guys, when you're taking a test. I had so many people today saying, why am I not getting this right? And they didn't read what the problem wanted. Round your answer to the nearest dollar. That would be 6,990. It could have been 6,991, but the 13 cents afterwards say I should round down, so I'm going to call it that. Okay? So that's the problem. Notice I did not put VT. I don't even think that would work. Let me try it. Yeah, it doesn't like that. So please, when you're trying to evaluate something for like a final result, just leave the Y or whatever thing they're using for Y out of it. All right. This is what we did a second ago. We made a formula for decay or growth. This time, they're not asking for the formula. They're asking you to find what the result is after 8 years. So we're skipping past the whole make the formula thing and finding the answer, but you still got to make the formula. That's part of the problem. So I'll do it on Desmos. The formula is the starting amount, A, 1. Now, this says the area of this forest decreases. So you have to read that and know to put minus. Could be plus, could be minus. I don't know. So I'm going to put minus 0.0475 because that is what 4.75% is. And I'm going to raise that to the... Now, earlier I had used t because I was making the equation, but here I want to know about specifically 8 years. So I'm going to raise it to the 8. Round your answer to the nearest square kilometer. 2, 7, 1 0. I do not need to round that up to 11. You know what's funny? It got really mad at me for not putting a comma in 220,000 or whatever, but it didn't care that I didn't put a comma in 2,000. I mean, wouldn't that have needed a comma? Consistency, Alex. All right, find the initial population size based on this. So we kind of saw this earlier. There was a question about initial size. This time it's 1,800. It's the number up front. And then this says, is it growth or decay? Now, we didn't get asked that earlier, but I did mention it because we had that problem with that 0.90. See how this number inside the parentheses is less than 1? That represents decay. If it had been a number greater than 1, it would have represented growth. But how much percent is this decay? If you put 75%, you are so wrong. If it's over 1 and you put a percent, you're probably, I don't know, don't put 100. The answer should be probably between 0 and 100. Okay, I'm not saying it's impossible to get over 100% growth. It's totally possible, but I don't think these problems are going to be like that. Now, okay, so the question is, how do I find the decay here? So what I'm going to do is I'm going to take the amount they gave me and subtract 1 from it. And it says negative 0.25, which tells me two things. The negative tells me that it was decay, although I don't need to put a negative on my final answer here. But I can't put 0.25. This is a decimal. I want to know what the percent is. You know how earlier I divided by 100 to make the decimal? Well, if I have a decimal, I multiply 100 to make the percent. I mean, it should be pretty obvious. 0.25 is 25%, but you know, sometimes the percent isn't as obvious. So basically it's this. You put the number up front as the initial amount. Growth or decay depends on if it's over 1 or under 1. And then the population change on this one, the percent of change, is based on how far the interior number is from 1. So in my case, mine was under 1 by 0.25, and that represents 25%. Final problem. And now we're getting back to these formulas again. I didn't use any of these formulas on the last problem, did I? No. I was just analyzing one. Okay, Joe borrowed $800 at a rate of 20% compounded quarterly. Assuming he makes no payments, how much will he owe after 7 years? Hey, it says something very important here, and you have to read it. And also, if you didn't get the gist of my message earlier, or if you skipped right to this part, problem 16 on here is compounded. So I'm wondering if question 16 on the test will be compounded. Or even better, maybe in life, just make sure you read the questions carefully, because compounded means you can't just use one of these basic formulas. You got to use the fancy compounded interest formula. So I'm not going to write A equals. I'm just going to start with P. In this case, P represents the principal, the starting money amount, 8,000. And then I'm going to put 1 plus the rate, which is 20%, which is 0.20. Now, I have to mention, some people I saw were putting minus because they saw the word borrowed and they assumed that means like decay. I understand. Borrowing is negative and bad, right? But you don't put a negative in here. The amount is going to grow because the amount of $8,000 borrowed, it will grow in value, and that's how much they'll have to pay back, which is obviously bad. You don't want to borrow $8,000 and pay back more, but I hope by the end of this problem you'll know that this could happen to you. You might end up paying back more if you borrow and you don't pay it back. All right, now here's the deal. I put plus 0.20, and we've done problems like that, but I have not yet put this fraction thing. Why am I putting a fraction thing? Well, you have to put it over n. What's n, you say? Well, n is how many times per year something compounds. So I'm telling you right now in the video, if you're watching the video and you're not familiar with all these, annual is once per year, semi-annual, twice per year, quarterly, which is what I have, is 4 times per year, and then you may get monthly, which is 12 times per year. Just keep in mind, annual is 1. Something annual happens once. And semi-annual means 2. Okay? I've seen people have the most trouble with semi-annual. So if you're watching this, semi-annual means 2. Don't forget. Okay, in the exponent, there also is an n. So I'm not going to just put 4 down here. I'm going to raise it to the 4 times the number of years I want to know about, which is 7. There you go. So I filled it all up. Starting amount. 1 plus the rate, 20%, compounded quarterly, so I put 4 and 4 to the 7. So after 7 years, you owe this much money. And this does say round to the nearest cent. I've been rounding to the nearest whole dollar on a lot of problems, or a whole number, or whatever. This time it does want 2 spaces after the decimal, because that's what cents is. Now, this is interesting. I've said this, I think, when I was doing the homework as well, but can you believe that if you borrow $8,000 at 20% and you don't pay a cent of it back for 7 years, you will owe $31,361? Is that a good deal or a not good deal? That is a bad, no, don't do that deal. Now, I don't know where in the world you would borrow $8,000 and not partially have to pay some of it back over the next 7 years. But if you borrow $8,000, forget it exists, and then the company that you borrowed it from comes back and says, you owe us this money plus this 20% interest you had agreed to at the time of borrowing. That's how much you'd have to pay, and isn't that terrible? If you have to borrow money, please borrow at a lower rate. Like if you borrow $8,000 for college, let's say, try and get it at a percent like 5%. Do you see how 8,000 only turns into 11,000 at 5%? That's a lot less than 31,000, right? So always try and go for lower percents when it comes to you borrowing money. Bad news, though, is you don't get a lot of chances in life to borrow at 5%. But try and take them if you can. Lower's always better. All right, anyways, I got mad about the comma, but whatever. Submit the assignment. Okay, I'm gonna quick run down all this stuff here. All right, so we had filling out a table. We had graphing a line using 5 points, which we used with a table. We had graphing another line with 5 points we used from a table. We had the domain and range. Number 5 was also the domain and range. Here, I'll still flash it on the screen here. There you go. Number 6, pardon me. Number 6 was yet more graphing, although the equations got a little more complex. 7 was graphing with slightly more complex equations. 8 was graphing, but you had to shift the graphs around based on the updated formula. And that was how 9 and 10 went as well. I don't really want to click on those, but 8, 9, and 10 were all that. So that is 10 out of 16 problems require you to have some knowledge of graphing. So I hope you have some knowledge of graphing, okay? 11 through 16 was these formulas. And I'm going to split this to show you that again. These formulas right here. So I created formulas with growth. I created a formula with decay for number 12. On number 13, we were given a formula and asked about some stuff. So we asked the initial value, and then we had to evaluate it at 13. Number 14, we didn't have to make a formula for the answer, but we had to kind of make the formula and then evaluate it at the same time. So it was kind of like a mix of 12 and 13 together. We make the formula, and then we use the formula to make the final outcome. Number 15 was evaluating parts of this, and I think the most complicated parts is it growth or decay? I had a lot of people having trouble if it's growth or decay. So remember, growth is over 1, decay is under 1. And by what percent, which means how far of a decimal is this away from 1? Mine was 0.25, which is 25%. So make sure you're careful in the conversion there. And then the last problem, it was a compound interest formula. So I properly filled out my compound interest with the relevant information. And bada bing, bada boom. All right, there we go. That was the review of graphing and writing exponential functions. And that's all I got for you. Hopefully, if you watch this, helps you out. And you are successful on your test when you see it. Thank you very much, and have a great whatever you're doing. Okay, bye.